So Apple's event earlier this week was really interesting. They announced a lot of foundational changes in the way that they're doing things when they think about LLMs and the new iPhone and Apple software, period. We now know that, unsurprisingly, they're partnering with OpenAI to integrate a lot of ChatGPT into iOS 18 and the latest iPhones. And what's interesting is I think the biggest headlines miss a lot of the most important things that Apple talked about. And Apple really likes doing marketing things. Of course, I'm not sure that rebranding AI as Apple Intelligence was really that clever or a great idea. But what's interesting is sometimes Apple, in an attempt to get bigger headlines and get more marketing attention, really misses what people would maybe really see value in. Sometimes they miss some of the bigger things that they themselves have spent millions of dollars and weeks and months of time working on. And in this video, I want to get into some of what that is. For me, a lot of that is work they've been doing on developing their own bespoke LLMs, not just built on top of existing research like we've seen before. Again, Apple Research functions in a really weird way, where they take a lot of the same product approach in terms of having very polished results with really clear application of what they're doing. But what's interesting is now that internal work has resulted in something that is on a level of innovation that I think you could probably compare to Apple's internal shift from Intel to Apple Silicon. They've completely reimagined how they want you to use these tools and what that means to deploy on Apple hardware. So today, I want to talk about LLMs on iPhones, Apple's new work around all of this research, and what it means going forward. So welcome to AI Flux. Let's get into it. So again, as I mentioned, Apple sometimes misses talking about some of the most exciting things they have just because it's kind of hidden behind a paper, or maybe it's a little bit too verbose and complex to talk about to a wide audience of, tech journalists from TechCrunch and Wired. And what I want to talk about today is Apple's incredible work, basically what they're calling on-device and server foundation models. So basically one of the first models that Apple has created internally with its own data sets and its own architecture. So basically what this is an iPhone LLM. It's an LLM intended to run on Apple Silicon, and it's pretty incredible. And it's incredible for a number of reasons, predominantly because it's a 3 billion parameter model that is really quite capable, that they're claiming rivals the performance of existing state-of-the-art 7 and 8 billion parameter models. And it doesn't just do text, it also does image recognition as well. And what's wild is on the latest iPhone, it's actually running at a shocking 0.6 milliseconds per prompt token at around 30 transactions per second, which is pretty cool. And it also uses LoRA on all layers. So what you can do with this model is kind of completely open-ended. And they also have a lot of tricks wrapped into this model to make it both performant and really capable, and much more capable than even models like Phi-3, which Microsoft, to be fair, was the first to kind of start experimenting with and thinking about how they could use them. But what's cool with Apple is Apple has both sides of this equation really lined up about as well as you could. They have the best hardware integration, they have very powerful software teams, and if they can try to get those to talk together and incorporate some of the research that's been done, there's a potential that Apple, in my opinion, could be basically a year ahead of everyone else in the space trying to deploy these. Even though, of course, there are forms of Llama C++ that are now on every Android device, but the experience matters. And even though I thought a lot of the features that were released on the new iOS 18 were kind of funny, this is really, really cool. And by funny, I do mean the fact that you can now change your icon colors and just do a lot of things that you could do on Cydia back when I was in middle school. But anyway, let's hop into what this model is all about. So Philip Schmid has one of the better write-ups about this model, and I think everyone here should go and follow him. So one of the big wins with Apple's model is that it basically is an on-device 3 billion parameter model with grouped query attention, activation, and embedded quantization running on their neural engine. And grouped query attention is something we haven't seen a lot of in models this small meant to run on edge devices. For instance, Phi-3 was really small and capable, but it was still quite difficult to run even on the latest iOS devices with some of the tooling that exists to do that right now. Go check out my video on running LLMs on iPhones if you want to see more of that. And what they also mention is that they have server versions of this model that are intended to run on Apple Silicon, basically servers built on M3 Ultra chips, which is pretty cool. I mean, frankly, I really want to buy one of those, but Apple doesn't sell those yet. And what's cool is to make these run faster, like I mentioned, they have a few tricks up their sleeve to make this work. Some of those are dynamic load, cache, and swap LoRa adapter models as you need. So for instance, for different languages or for different apps, there is a chance that the way you would run apps on this is that there'd be kind of a core set of functions, and then you could include a LoRA with your app and get all of the wins of having full LLMs without actually having to do a lot of the tooling, which I think is an incredible step forward in terms of just how developers interact with AI on edge devices. We pretty much know that the idea that you would have a full model loaded from like an app store is not really a great way to do this. So Apple, again, thinking with a product first mindset, puts them ahead of everyone. I mean, obviously, even if the Qualcomm chip that Microsoft is using, even if they think that's faster than the M4, again, if you don't have the tooling behind it and a really deep understanding of how developers might interact with it, a lot of it just doesn't matter, like just straight up. What's also cool is they've used ablation, or what they're calling rejection sampling, in order to optimize and actually do really thoughtful RLHF of these models. They've also used a lot of synthetic data, which is pretty cool, and their eval samples I think were reasonably picked because the benchmarks did really come through, and it doesn't look like they were juicing these numbers too much. This also uses Apple's AX-Learn framework based on JAX and FSP to train on TPUs and GPUs. So one thing I would have never expected is Apple actually using TPUs to train this, which is kind of really surprising. And the biggest wins that Apple wants to talk about right now is that their 3 billion adapter basically outperforms Phi-3 on common LLM tasks. And in terms of a number of other evals, specifically from IF eval, and a number of evals that were developed to test GPT-4. Again, the 3 billion parameter adapter achieves essentially equivalent performance or better performance in most cases. Now, the one thing that I think Apple missed with announcing these numbers is they didn't do a great job of really explaining what the difference between on-device or Apple Server is. So again, Apple Server is likely a larger version of this model, or a version of this that is using certain optimizations a little bit less so that you're just getting more kind of full precision-esque performance. So it's still Apple Silicon, but it's much bigger Apple Silicon than you would see on an Apple device. And on-device basically means like leaning towards an iPhone. Obviously, there's a spec of the M4 that you're going to see in iPads, that you're going to see in iPhones, and somewhere in there is the on-device or mobile device, and then Apple Server is a full-on desktop M4 or M3 in this case processor. And they also include their human preference. And it's important to note that, again, these benchmarks are kind of their own human preference numbers, so kind of just what people think, and IF eval benchmarks kind of to show what's going on here. Now, obviously, they've been a little bit picky, but what's cool is the numbers did add up. So in terms of people interacting with these Apple services, basically, people generally preferred the Apple version of what was given here. So basically, this is showing, for people who were using a number of these different models, when presented with Apple's 3 billion parameter adapter, which did they prefer? And this basically shows in most cases that, at least when you're comparing to larger models, in most cases, people actually preferred the Apple models at least a little bit more than half the time, which is statistically significant for this. And what I think is interesting here is when we look at GPT 3.5 Turbo and GPT-4 Turbo. And I think we see this result because just so many people use this. If you're going to do a focus group, the people who are going to say they would prefer it have just probably used the service more and would likely just prefer it because they know how to use it more, which I think is kind of interesting. What I do also think is cool is the product first focus of Apple also shows up in these benchmarks, because what they pick is an AI suggestion as a result of a notification or as a result of an email. So the idea here is you're presented with an email and it's giving you kind of a predictive text of, oh, what would you like to do here? And clearly the satisfaction was quite good. On the mobile device, maybe is a bit more work to do. But what's cool is when it comes to synthetic benchmarks, which I think in this case are probably something we should trust more than focus groups run by Apple, you can see that clearly the level of performance is stunning. And the biggest one is that Apple's server implementation of this model is basically matching the performance of GPT-4 Turbo, not even just GPT-4. Now, it's interesting that they only picked GPT-4 Turbo, not GPT-4. So there are some questions there, but the other huge win is that by a massive margin, Apple's on-device model is clearly winning out against basically every previous state-of-the-art 7 billion parameter model, even ones from Google, and specifically Phi-3 Mini, which Microsoft has been clear was intended to be used on mobile devices. So the irony is, even with a basically year-old Apple Silicon, they are already beating the model intended to run on what Microsoft calls is faster hardware in terms of NPU from Qualcomm, which is pretty cool. So now the question is, how do these benchmarks actually stand up? And they stand up really, really well. And Apple's been hinting at this for some time. We knew their benchmarks were quite good with their M1 model suite they announced back in March. But yeah, it's cool to see this model actually pull through. Obviously, they're probably not using M1 exactly, but it is cool to see. And there are even more interesting details that have been released in their official paper that has some cool videos. Which you should definitely go read, and I'll link below. So a lot of what they get into here is how they're collecting data and what they're actually doing with it. And what I don't understand is why they're actually integrating ChatGPT in iOS 18, which means that they're basically sharing all of that data flow with OpenAI. Frankly, I just want an OS that doesn't have a lot of this AI stuff baked into it, but frankly, Apple makes the most compelling case going forward. And predictably, Microsoft picked the creepiest version of that going forward. So the big things they mention here are using Apple's AX Learn framework for pre-training, which I think is pretty cool, especially when it comes to sharding parallel data. And again, mentioning they're using both TPUs and on-premise GPUs. It'd be really interesting to know exactly what those were. They also mentioned post-training. Curiously, Apple is still really into RLHF, which a lot of the industry has kind of moved away from. So it's interesting to see Apple taking their own path there. And then optimization is obviously one of the biggest factors here because this model was really intended to run on edge devices. So then they mentioned a lot of their benchmarking methodology, which is interesting. But yeah, so one of the things I want to talk about kind of as some takeaways from this model are what edge compute really means. And edge compute, a lot of times people just roll their eyes at it and they think, oh, what are they going to do? Find a new way to do basic image stuff, or like why would you bother basically with these really small models when Grok is so fast and cellular data is so cheap? And my answer to that would be you have to look at what compute we're actually doing on the edge. And Karpathy actually had a really great tweet about this today. That's actually the focus of an entirely different video I'm doing. And basically that was 5 years ago, we a lot of times thought, oh, well, we'd have to do things as simple as server-side rendering for font elements and things that we thought, oh, there'd be no way you'd ever have enough compute on a phone to do that. And now the things we do on the phone that are effectively free. So what's cool is when you take tasks that you thought you had to do in expensive clouds and then bake them into a device, it enables developers to do more. It enables a lot of things just to happen on software apps, on apps in general that wouldn't happen. And although, Grok is a very interesting sort of bit of metal that has been thrown into the jet engine that is ML tooling and how we think about inference and how we do that on the edge, what I think is interesting is this changes all of that. So basically, it means if you're going to develop an app and you want it to be used by millions of people, the bigger headache used to be how you would run inference for that, or like how much your bill to make a GPT wrapper would be for that. And now, in theory, again, if the person's device has this capability, it's basically free. So it enables more people to use the platform. It enables more things to be done generally. And for the kind of lower bar of what people want to use LLMs is to be raised quite substantially. So I think this is pretty cool. I think, again, it sort of opens the Overton window for what we can actually do on Apple devices and Apple just as an AI ecosystem. And no, I'm using AI for artificial intelligence, not Apple intelligence. So I'm curious what you guys think. Do you think this is really a big push forward in what it means for state-of-the-art edge compute for LLMs on mobile devices? Are you using any LLMs on MLX or on Apple Silicon? I think Apple Silicon is going to keep becoming more and more pervasive in the local LLM space just because of how much more accessible it is and really how powerful it is. And showing that Apple is actually using these on quote-unquote servers shows that I think we're going to continue to see really cool advancements from Apple, maybe even an attempt from Apple to do something similar to Grok. So let me know what you think in the comments below. I'm really curious if you guys think this is kind of dumb. I generally thought the Apple announcement at WWDC this year was kind of funny because it was all just about ChatGPT and we all knew that was going to happen. But yeah, so as always, I hope you learned something in this video. If you like this video, please like, subscribe, and share, and we'll see you in the next one.